All right, so today we're going to go over corresponding parts of congruent triangles are congruent. We use we abbreviate this as CPCTC, so we only use this to prove that parts of triangles are congruent. So that means that we have to use one of our other triangle congruency statements. So like side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg first, and then we can use CPCTC in a proof. So for problem number 1, we're given that segment AB is parallel to segment DE and segment BC is congruent to segment DC, and we have to prove that segment AC is congruent to segment EC. So I'm noticing here, this is talking about parts of two triangles. So I'm going to try and prove that the two triangles are congruent first before I can say this statement. So I'll start with my statements and reasons. Every time I do my proofs, I always like to start with the givens first. So I'll start with segment AB is parallel to segment DE. Remember, we use these little arrow marks to indicate that two lines are parallel, and that is given. And then we have segment BC is congruent to segment DC. So they have, oh how nice, they have that marked for us. So that is given. So now I'm going to go back up and say, okay, so if I know these two lines are parallel, then I remember from our parallel lines with transversals unit that I could possibly get some angles to be congruent here. So I'm noticing here that since these lines are parallel and I have this transversal here, that I would have an angle at B and D that I know would be congruent because those are alternate interior angles. So we can say alternate interior angles are congruent. It's one of those theorems. And then I could also say, I'm noticing I have vertical angles here. So I could say angle BCA is congruent to angle DCE because we know that vertical angles are congruent. So now that would tell me I have an angle, a side, and an angle marked in my triangle. So I know triangle ABC is congruent to triangle. Now remember, we have to match up our angles here. So angle A matches with angle E, angle B matches with angle D, and then angle C matches with angle C. So we have triangle ABC is congruent to triangle EDC by angle side angle. And since we know that those two triangles are congruent, we can now say that segment AC is congruent to segment EC because of corresponding parts of congruent triangles are congruent, or CPCTC. So let's try another one. Statements and reasons. So this time they told us segment AC is congruent to segment EC and segment BC is congruent to segment DC. And we have to prove that angle B and angle D are congruent. So I'm noticing these are talking about parts again, right? It's part, they're angles of a triangle, so they're part of the triangle. So I have to prove that these two triangles are congruent first. So I'm looking at my reasons up here saying I have to prove that those two triangles are congruent first. So I'm going to start with my given statements. So I have AC is congruent to EC, and that was given. I'm going to mark that on my triangle. So AC is congruent to EC. And then I was told BC is congruent to DC. So segment BC is congruent to segment DC. So I'll mark that on my triangle. That was given. So looking at these two triangles, I'm noticing I have a pair of vertical angles here. So I know that my vertical angles, so angle BCA would have to be congruent to angle DCE because vertical angles are congruent. And then that means I could conclude now, since I have a side, an angle, and a side marked, I can conclude that those two triangles would be congruent. So I'll name my first triangle ABC. Would have to be congruent to triangle. Now I have to match up my angles. So angle A matches with angle E. Angle B matches with angle D. And angle C matches with angle C. So I get triangle ABC is congruent to triangle EDC by side angle side. And now that I know that the two triangles are congruent, that means all of their parts have to be congruent. So I can say angle B is congruent to angle D by CPCTC, where corresponding parts of congruent triangles are congruent. All right, so then for example 3, this time we're given segment AC bisects angle DAB and segment AB is congruent to segment AD. So I'll do my statements and reasons. So I'll start with my givens. So I'm given segment AC bisects angle DAB. All right, well, there's no great way of being able to mark bisect, so I'll come back to that because we got to talk about that. And then we have segment AB is congruent to segment AD, and that is given. So I can go ahead and mark that. So AB is congruent to AD. So let's go back to this bisect. So I'm thinking, okay, so when it says something bisects something else, that means it cuts it in half. So I would get two congruent figures. So I'm looking specifically, it's bisecting angle DAB. So if I look, angle DAB is this angle here. So if it bisects this angle, that means it cuts it in half, so I have two congruent angles there. So that's what I'm going to say is angle BAC is congruent to angle DAC, because since it was bisected. So this would be our definition of an angle bisector, because we were told that AC bisected the angle. So that's how I knew those two angles had to be the same. And now I'm looking, hey, these have a shared side. So I remember my shared side. So segment AC would be congruent to segment AC because of the reflexive property. Remember that says something is always equal to itself. So now I can say that my two triangles would be congruent. So triangle BAC would be congruent to triangle, let's see here, so B matches with D, and then A would match with A, and C would match with C. So triangle BAC is congruent to triangle DAC by side angle side. And now I can say angle B is congruent to angle D because of corresponding parts of congruent triangles are congruent, or CPCTC. All right, so then for example 4, do my statements and reasons again. This time, we're told that C is the midpoint of segment AE and segment BD, and we have to prove that segment AB is congruent to segment DE. All right, so I'll start with my givens. C is the midpoint of segment AE. That's given. And then C is the midpoint of segment BD. And that is also given. All right, so I don't really have any notation that I can say here for C being the midpoint until I get into what does it mean to be a midpoint. So a midpoint means that it's in the middle. So that would cut the segment in half since it has to be in the middle. So since I know C is the midpoint of AE, I could say segment AC has to be congruent to segment CE. So this segment and this segment have to be the same because C had to be in the middle. And this is because of the definition of midpoint. And then we have a similar process for the other side, right? Since C is also the midpoint of segment BD, so I can say BC and CD are congruent by the definition of midpoint. So then we would get, I see vertical angles here. So angle BCA would have to be congruent to angle DCE by vertical angles are congruent. So now my two triangles are congruent. So triangle ABC is congruent to triangle, let's see here, A matches with E and D matches with B and C matches with C. So I get triangle ABC is congruent to triangle EBC by side angle side. So now I can say my proof statement. So segment AB is congruent to segment DE because of corresponding parts of congruent triangles are congruent. That's it. So pretty much all that I have to remember for all of these is in order to be able to prove that parts of triangles are congruent, I have to start by proving that the two triangles are congruent in the first place.